Coming here in person is so much better. I've tried to watch talks online. It can be harder to concentrate, there's so many more distractions at home. But here as well, you can actually ask the presenters questions. You can talk to the person sitting next to you, and you can talk with the presenter afterwards in the hall. It's really a totally different experience than just being here virtually.
This is the better expressiveness with parallel range algorithms. This is the basically end of my talk that I didn't have time to deliver. If you weren't on my talk, shame on you, but you're going to have like just a little bit part of it. So what I'm going to show is literally like 2 slides. We have the function that has like word count, and it just does basically the algorithm that it does the sequence, and it uses the algorithm that can take 2 sequences. In this case, we use transform reduce in parallel with state execution part, as you can see. And also, we passed it like 2 sequences, but I mean 1 as 2. The first one is like 1 symbol less, and another one is also 1 symbol less, but starts with the second symbol, not with the first one. So 1 is cut from the end, 1 is cut from the beginning. And now we're gonna compare. We need to do transform reduce because I think we don't have anything better in C++ 17 without parallel range algorithms. So we're gonna do transform and reduce. And the funniest thing that transform reduce takes reduce function first and transform function second. So in the second function, in transformation, we're gonna do if the symbol that we got is not alpha, and the second symbol that we got is alpha. And we're gonna count that this is the beginning of the new word. And we're going to convert it to int because we need to reduce after that. So we reduce all the ints, and that's how we calculate the number of words. Does it make sense? Yeah, and then there is some, at the end, there is a corner case handling, which doesn't matter for the purpose of this talk. Then, what we have with ranges. We now use countif, which is much more logical for this use case, right? We use zip, which does exactly the same, cuts the same sequence, like 1 from the end and another one from the beginning. We use this like zip with text is piped with take view, and then comma zip text with pipe is drop view. And then we have lambda, which does again the natural thing. We unpack this zip view, basically tuple of references by structure byte, but S1 and S2, and then return bool, as we should, whether it's like a start of the new word or not, by basically having the same check. This first symbol is not alpha, and the second symbol is alpha. Cool? Yes. Cool. That's it. Thank you very much for attention.